Ukraine has struck again, this time targeting one of Russia's largest oil refineries.
A Ukrainian drone swarm broke a layered air shield, and a $7 billion Russian oil refinery at Ryazan took the hit. The site feeds tanks near Moscow, keeps jets moving, and channels cash into a wartime budget, so any outage bites far beyond one fence line. A low-flying mothership led 10 fast FPV drones, hugging ground to stay beneath radar beams and tracing a path through blind spots. Decoys drew the lock, a compact jammer opened a 10-second blackout, and the main group slipped inside the ring. The first strike lit a pipe rack, a damaged drone turned into a torch, and two final hits drove at a cracking unit and a storage tank. Satellites caught the plume, command nets tightened, and markets read the signal. Tools that cost thousands just forced choices that cost billions. Why Ryazan mattered, how the route was drawn, and how a 10-second window bent a powerful air defense. Stay with military force for the next breakdown. Strategic value turns Ryazan into a choke point for Moscow's war machine, because the plant feeds fuel to forces, airports, and factories across the capital region. The site produces multiple streams: gasoline, diesel, and jet fuel, so one outage touches ground troops, civil transport, and air operations at the same time. Pipelines tie the facility to storage hubs around the city, while rail spurs move product to depots that stage convoys and resupply units. When that flow contracts, vehicles wait for tankers, commanders shorten patrols, and routine training burns into scarce reserves. Military logistics depend on predictable fuel, and this plant anchors that rhythm. Armored brigades need diesel for columns and recovery crews. Artillery battalions need trucks for shells. Air bases need aviation fuel for sorties and alert scrambles. If one source near the capital falters, the network must pull barrels from farther refineries, which adds time, cost, and security risk on every mile. Convoys carrying fuel become targets, schedules slip, and a small delay at the hub grows into missed windows at the front. Design choices inside the plant make select units especially fragile, so a precise hit can disable far more than one pipe. Cracking trains raise throughput and unlock lighter products, yet those reactors depend on heaters, compressors, hydrogen supply, and control rooms that share power and sensors. Damage to a cracking unit, a substation, or a main manifold forces operators to shut connected lines to prevent runaway reactions, which reduces output across the site. Large storage tanks multiply the risk because a puncture near full capacity can feed flames and force wider isolation while firefighting systems flood the area. Even when crews keep the core intact, inspections, cooling cycles, and repairs stretch downtime, and each extra day drains inventories around the capital. Civilian and military effects stack, and the economics compound the pressure. Buses, ambulances, and municipal fleets lean on steady diesel. Airport ground services and airlines need reliable jet fuel. Harvest seasons and long-haul trucking cannot pause. When local supply dips, distributors chase barrels from distant plants, rail slots tighten, and bids rise, so households and small firms feel cost pain within weeks. Government budgets also take a hit, because refined products feed tax receipts and export margins that fund procurement and social spending during wartime. A visible fire at a flagship facility shakes confidence, triggers inspections at other sites, and nudges traders to price and disruption risk around the capital. That is why Ryazan functions as both a gas station and throttle for the Moscow military district, and why a carefully timed strike there echoes far beyond one fence line. A single, well-placed blow can slow convoys, trim air hours, and force costly reroutes, while the public sphere absorbs higher transport costs and tighter supply. The calculus favors precision over mass. Disrupt the unit that sets the pace, and the entire region must move slower. Next comes the method that made disruption possible: an approach drawn at low altitude, a mothership that carried a swarm, and a brief window that opened the gate. The approach relied on a mothership plus swarm design, as a Sokol 300 carried 10 FPV strike drones along a terrain-hugging route to the edge of Ryazan's defenses. The big airframe did the long haul, while the small craft saved batteries and exposure for the final dash, so risk stayed low until the last mile. Flying low kept the formation under most search beams, and each ridge, tree line, and rail cut added another mask from ground-based sensors. Route planning leaned on satellite imagery for the static picture and scout UAVs for live gaps, so the flight path threaded silent corridors between radars and patrol arcs. The goal was simple yet demanding: arrive near the perimeter with the payload intact, then separate the knives from the sheath and strike where one hit could shape the whole outcome. Staying low mattered because physics favors the attacker when altitude is small and distance to sensors is long. The Earth's curve hides low flyers beyond a short horizon, and ground clutter makes small cross-sections harder to track, so detection windows shrink. Valleys broke line of sight, industrial heat plumes muddied infrared, and night haze reduced contrast for optics, so the signature picture stayed messy for the defenders. Noise discipline also mattered. Brief directed transmissions limited reveals, while preloaded waypoints and tight procedures kept the flight quiet until release. Navigation did not depend on one tool alone, and inertial units bridged short jamming zones, so spoofed coordinates could not force a stray. The mothership choice traded numbers for certainty, and that trade favored a clean entry. Launching many long-range drones invites attrition across a wide belt, yet one carrier brings the package close, so the swarm crosses only the inner rings. 10 FPVs on the hardpoints gave flexibility, some for diversion, some for sensors, most for strikes, and one reserved for an emergency role if the plane bent under fire. The carrier did not need to loiter. It only had to reach a release box outside the densest short-range systems, drop the payload, and exit on a pre-planned leg. That sequence cut exposure time for every asset, and it kept the cost curve low because the expensive airframe avoided the hottest air. Timing and spacing turned a plan into a corridor. Wind, temperature, and cloud sealing set the safe height over wires and towers, while fuel margins fixed the latest release time, so the team locked a narrow clock window. Separation distances between FPVs prevented mid-air conflicts, yet kept sensors and decoys close enough to share the same slice of sky, so every move supported the next. Staggered altitudes reduced collision risk and gave options against guns and missiles, while a common ingress axis simplified human control in the terminal phase. If a gap closed, a branch line existed. If a jammer appeared, an alternate angle was ready. If a scout saw a patrol, the whole formation slid to the next lane. This is why the bring it close, hit it hard method fit the target and the defenses that ringed it. A single carrier concentrated range, 10 FPVs concentrated on effects, and the ground-hugging route concentrated surprise, so the strike package reached the point where short actions decide big outcomes. The last requirement was a brief blindfold on the outer sensors and a clean distraction for the inner guns, and that sets up the next step. A 10-second blackout, 2 decoys up high, and a path opening at exactly the right moment. A 10-second blindfold turned a strong air shield into a door, because 2 climbing decoys pulled the locks, while a compact jammer flooded the fire control receiver with noise. The bait rose fast to be seen. The blinder fired once the beam tightened, and the main group skimmed under the cone before operators could switch modes. That small window mattered more than raw firepower, since tracking radars work best when they stare, not when they search, and the trick forced a stare in the wrong place. Layered sensors set the stage for this trap, as the 91N6E Big Bird scans wide while the 92N6E Gravestone guides weapons with narrow, high-gain beams. Nebo M families add range and altitude coverage, yet the kill depends on the moment when a fire control channel commits to targets that look urgent. Decoys exploited that habit by climbing above clutter and showing a clean, bright shape, so engagement logic favored them over anything low and masked. Once the lock hardened, the battery's attention compressed, and the rest of the sky became a lower priority for a few heartbeats. The jammer worked because distance and geometry favored a small transmitter close to the victim receiver. Short range raises effective power at the radar's front end, so even a lightweight pod can saturate side lobes and smear returns for a brief slice of time. The burst stayed tight and short to avoid easy geolocation, and the carrier kept line of sight long enough to spoil tracks without lighting the whole belt. This was not about winning an electronic duel for minutes. It was about dirtying one picture just long enough for the real strike to pass a gate. When signal-to-noise collapsed on the engaged channel, track quality fell, and auto-cue to inner guns lagged by the seconds the attackers needed most. Low flyers made the most of that gap because ground clutter hides small cross-sections and shrinks the time available for clean locks. Treetops, ridgelines, and buildings broke line of sight, while heat plumes and haze dulled optics, so the main group stayed in the weeds until the last turn. Brief directional links handled handoffs, and inertial units bridged short jamming bubbles, so spoofed coordinates could not push the swarm off course. By the time the outer ring recovered, the formation had crossed into zones where reaction shifts to short-range systems, and even a smooth handover cost beats. Those beats translate into fewer guided shots, more hurried gun bursts, and a higher chance that at least two vehicles reach decisive aim points. Cost and effect tilted the equation because cheap decoys and a single blinder forced premium hardware to waste focus and time. The battery burnt missiles on the obvious climbs, the console showed clutter where clarity had been, and the inner crews reacted without the best cues. Counters do exist: more passive sensors, wider band coverage, faster data fusion, and tighter drills between outer radars and point defenses. Yet each fix adds expense, training load, or extra emitters that can still be gamed by timing and angles. That is why a short blackout, two loud lures, and a quiet main body can bend a strong system just long enough to matter, and that timing sets up the next phase. Staged strikes that light a pipe rack, stretch the defense, and open clean shots at the heart of the plant. The strike unfolded in stages to overload sensors and split fire, starting with a clean hit on a pipe rack to build a tall column of heat and smoke. The first blast forced cameras to stare into glare, while thermal viewers lost contrast inside a hot, dirty plume. Operators had to check for leaks, close valves, and move teams with breathing gear, so attention split between firefighting and tracking small threats. Gunners could not see past the soot, and rangefinders struggled through flicker, so point defenses lost the steady picture they needed for fast shots. That single choice, ignite a visible hazard first, turned a protected plant into a maze of blind corners. Fire then became a weapon that shaped every next decision, because spreading flames created both danger and doubt. Foam cannons need space and pressure, yet hoses and crews cannot work under falling debris, so commanders redirect units to safer angles. Heat updrafts bend air and add shimmer, which distorts optics and makes small drones skate across screens. Fans and extractors push smoke along service roads, and that wind carries sparks toward cable trays and catwalks, so more zones need isolation. Every new safety cordon removes another firing position, and each detour adds seconds that attackers can spend on aim. A damaged FPV became an asset, not a loss, when it dove into a spreading fuel slick and turned a spill into a torch. This improvisation showed control discipline, because a crippled airframe still carried enough heat to light a wider area. The sudden flare forced more pumps offline, and deluge systems dumped water and foam where gunners wanted clear lines. Thermal cameras bloomed again, and smoke hid low flyers skimming under cranes and conveyors. With visibility broken, defenders fired shorter bursts, paused to re-identify, and lost tempo across the inner ring. Multi-axis pressure grew while the blaze advanced, because alarms do not ring in sequence during an industrial fire. A siren near the rack, another near a manifold, and a third near a substation pull people in different directions. Radio nets fill with partial reports, and map boards show too many red marks, so leaders triage tasks and accept risk at the edges. Missile crews conserve shots, guns switch to manual, and reload drills collide with hose teams in narrow lanes. Even when training holds, the whole guard force fights two battles at once: a moving fire and a set of small, fast targets. Process design amplified the effect, since modern cracking trains rely on linked utilities that do not like sudden heat loads. Switching off a unit to prevent runaway reactions reduces flow across shared lines, and pressure swings ripple into other sections. Maintenance rules demand cooldowns and inspections after high-temperature exposure, so restarts take time even if core hardware survives. Meanwhile, external supply must cover the dip, and every truck or rail car that fills the gap needs protection and scheduling. That logistics drag starts at the fence but stretches far past it. The net gain for the attackers was time, cover, and choice, because staged fires stole clarity from the defenders and opened lanes to decisive aim points. Low platforms could turn around supports, pass under scaffold, and set up terminal runs without long exposure. Inner weapons still had reach, yet their cues were late and their sightlines were dirty. This is why the middle phase mattered. A lit rack, a spreading burn, and forced dispersion created the opening for the final pair to drive at the core systems next. The finishing blow targeted the AVT-6 cracking unit and a nearby crude tank, because stopping those two assets shutters the core of the refinery. A shaped charge jet slices steel, then injects heat and pressure into tight spaces, so valves slam shut and control rooms order an emergency stop. The reactor train depends on steady temperatures and clean feed. A puncture forces shutdowns to prevent runaway reactions and coke buildup. The tank strike turns stored fuel into propellant for fire, and overpressure ruptures seams that sprinklers cannot immediately tame. Once both hits land, throughput collapses, flare stacks roar, and operators fight to contain a complex that no longer breathes on its own. Damage at a cracking unit cascades through shared utilities, so one hole can idle multiple sections. When AVT-6 goes down, connected heaters and exchangers must cool by the book, and instrumentation needs inspection before a safe restart. Cooling cycles take hours, sometimes days, and every delay drains local inventories that feed the capital region. The tank rupture amplifies chaos, because a boilover risk forces wider isolation and longer cordons. Heat shimmer blinds optics, smoke confuses thermal sights, and falling debris blocks firing points, so point defenses lose clean lines. Fire commanders choose life safety first, then plant integrity, so security teams accept blind spots near the burn. That trade buys attackers minutes, but it costs the site days of controlled cooldown, inspection, and staged restarts. Those numbers require corroboration, yet the direction tracks with basic logistics. When a major hub goes dark, barrels must travel farther, and the last mile gets more expensive. Distributors chase supply from other plants, rail slots tighten, and bid prices climb, so transport costs ripple into households and small firms within weeks. Military demand cannot shrink on command, so civilian users absorb more of the squeeze. Replacing a damaged cracking unit takes money, time, and specialized parts. Guarding every tank and rack takes manpower that air defenses cannot supply. Extra Panzer batteries and more patrols help, but soft targets remain until redundancy, passive barriers, and low-sky counter-UAS fill the gap. That is the strategic lesson of the terminal strike. Precision at the core beats volume at the edge, and the price of a small tool can rewrite a big balance sheet. Next comes the closing takeaways and the signals to watch, as both sides adjust to a battlefield where cheap, smart teeth keep testing heavy armor. The core lesson is clear. Precision and timing beat price tags in modern war. A swarm that costs thousands can bend a shield that costs billions, if scouting is steady and coordination is tight. One short blackout can shift the picture, and a clean route at low altitude can turn gaps into a corridor. After this strike, the contest moves to the low sky where point defenses, passive sensors, and faster command links matter more than tall radars. Expect denser CUAS rings around refineries and power sites, plus drills that cut reaction time by seconds. Expect attackers to double down on mothership tactics, stronger navigation, and smarter decoys that waste missiles and break focus. The next signals will be visible to anyone watching carefully. Look for heat signatures in satellite fire maps, tighter fuel markets near the capital, and new counter-drone posts on plant perimeters. If those signals stack up, the balance shifts again, because supply lines slow when protection thickens. And when timing slips, fewer sorties launch and fewer convoys roll. The side that learns faster will shape the lane before shots are fired. For sharp, field-tested analysis and early reads on the next move, subscribe to Military Force.